In 1965, physicists Arno Penzias and Robert Wilson accidentally discovered a faint interfering signal during their experiments, which became known as cosmic background radiation. This radiation consists of microwaves that hit the Earth very evenly from all directions. Here we see a map of this radiation, which is assigned a temperature of about 2.7 Kelvin. Because of its high uniformity, this is called the monopole. In Big Bang cosmology, this is believed to be the afterglow of hot matter when the balloon universe was approximately 370,000 years old. Over the billions of years since then, the extremely strong radiation emitted at that time is said to have been redshifted by a factor of Z equals 1,100 to the intensity observed today. When this microwave radiation was discovered in the 1960s, it was hard to imagine what could produce such radiation, apart from a gigantic explosion. Not much was known about the large quantities of cosmic plasma. This ignorance, coupled with the desire to find an echo of the Big Bang at all costs, initially led many cosmologists to believe that they had now found solid evidence for the Big Bang. But after radio astronomy detected more and more interstellar and intergalactic plasma, it became quite possible, if not likely, that it was precisely this surrounding plasma that could produce the microwave radiation. In the late 1980s, plasma physicists Anthony Parrott and Eric Lerner investigated this possibility in more detail. When the electrons of a plasma filament spiral in a magnetic field, they emit so-called synchrotron radiation, just like any accelerated particle. Kirchhoff's law of radiation states that any object that emits radiation of a certain frequency is also capable of absorbing radiation of that frequency. This means that the electrons of the surrounding plasma can absorb microwave radiation from stars and galaxies and radiate it in random directions. After some time, this creates a uniform microwave fog. This would therefore be a very local phenomenon, and in such a case, it would be better to speak of an intergalactic or even interstellar background radiation. By analyzing 237 galaxies, Eric Lerner was able to prove that these galaxies continuously produce microwave radiation. He summarized his research results in his 1992 book, The Big Bang Never Happened, as follows.
The cosmic background must, in fact, be generated locally, near to our galaxy, by an intergalactic medium that absorbs and emits radiation, so the microwave background is not the echo of the Big Bang. It is the diffuse glow from a fog of plasma filaments, the hum from the cosmic power grid.
In addition to synchrotron radiation, there are other processes in cosmic plasmas that could produce a uniform microwave radiation. The aforementioned Jacques Moret-Bailly stated with regard to the Raman effect.
ILCRS, incoherent light coherent Raman scattering, is not a simple alternative to the Doppler effect. The energy lost by the redshift of hot beams is transferred to thermal radiation generally at 2.7 degree Kelvin.
The special form of the Compton effect, with which Dr. Brynjolfsson, already referred to in Chapter 1, explains the cosmological redshift, could also be responsible for the background radiation. He writes,
in spite of the frequently quoted proofs and the contention that only the Big Bang hypothesis can explain the CMB, we will show that the plasma redshift cosmology gives a rather simple explanation of the microwave background. The intergalactic plasma will gradually absorb the photon energy. The plasma acts as a black body cavity. The free electrons are mainly responsible for the emission. The CMB radiation, which is emitted by the plasma, can be scattered many times and will be uniform and anisotropic.
Considering the vast amounts of cosmic plasma, we now know of several processes that can continuously produce uniform microwave radiation, as we see here. There is no good reason to believe that this radiation is the remnant of a huge explosion 14 billion years ago. In 1977, the American physicist George Smoot discovered a faint underlying signal in the monopole. This signal, known as the dipole, is due to the movement of the Earth, the Solar System, and the Milky Way in the plasma fog. The resulting temperature fluctuations are in the range of 0.0034 Kelvin and thus form a signal about 1,000 times weaker than the monopole. Correcting for the various movements, even tinier fluctuations in the range of 18 microkelvin remain, which are clearly produced by the Milky Way. In other words, within the dense fog created by the intergalactic plasma, we can detect the very faint glow of our galaxy's plasma. This confirms that our galaxy does indeed produce microwave radiation and that other galaxies will do the same. Cosmologists could have been satisfied with these results, had it not been for their conviction that the microwave radiation had to come from the edge of their balloon universe and should provide information about the formation of the first galaxies. Therefore, the satellites COBE and WMAP were launched to measure the tiniest anisotropies in the background radiation. Here we see the final result, which is presented to the public as a major success. There are minimal differences in the mostly homogeneous microwave radiation. These anisotropies are thought to have formed galaxies in the young universe. What is very rarely mentioned, however, is the far-reaching data manipulation that had to occur in order to get to this map. The work of Pierre-Marie Robitaille is of interest here. Robitaille is a professor of radiology at Ohio State University and a leading authority in the field of magnetic resonance imaging. It is not uncommon for this medical examination technique to be employed in matters of life and death. This means that errors in data analysis cannot be tolerated. With this background, Robitaille examined the data from the COBE and WMAP teams and found that they did not in the least meet the demands of medical imaging techniques. He writes,
"In actuality, the WMAP team must overcome virtually every hurdle known to imaging: foreground contamination and powerful dynamic range issues, low signal to noise, poor contrast, limited sample knowledge, lack of reproducibility, and associated resolution issues. It is clear that the generation of a given anisotropy map depends strictly on the arbitrary weighting of component images. The WMAP team attempts to establish a most likely anisotropy map using mathematical tools, but they have no means of verifying the validity of the solution. Another team could easily produce its own map and, though it may be entirely different, it would be equally valid."
Or equally invalid. Robitaille lists so many problems that they cannot all be dealt with here. I just want to say a few words about the contamination caused by the galactic signal. Robitaille states,
WMAP images are obtained by attempting to remove a galactic foreground contamination, which is 1,000 times more intense than the desired signal. This is accomplished without the ability to affect the signal at the source and without a priori knowledge. Resulting WMAP images have an exceedingly low signal-to-noise, maximum 1 to 2, and are heavily governed by data processing.
This means that the cosmologists involved act as if they know exactly what the galaxy's signal looks like, down to the smallest detail. Through elaborate, years-long computer calculations, they pretend to be able to remove the galactic signal. But how could anyone decide whether 1,000th of the radiation from this region does not come from the galaxy, but from the edge of the universe? It's like saying that when you're standing on NASA's observation deck, you can hear the words of an astronaut while the space shuttle is taking off.
Firing chain is armed. Sound suppression water system activated. T-minus 10, 9, 8, 7, 6, 5, 3, 2, 1, 0, and liftoff of Space Shuttle Atlantis on the mission to build and resupply.
As Robitaille meticulously demonstrates, the galaxy's comparatively powerful signal cannot be subtracted in order to assume the leftover noise and artifacts from the applied filters are an independent signal. Here we see the MRI of a wrist with a signal-to-noise ratio of 40:1. Accordingly, the picture is quite clear. Here is the same picture with a signal-to-noise ratio of 2.5:1. Practically all data is lost. The signal-to-noise ratio of WMAP is typically in this range. Robitaille therefore concludes,
Each map is indistinguishable from noise. The WMAP team is unable to confirm that the anisotropic signal observed at any given point is not noise. The act of attributing signal characteristics to noise does not in itself create signal.
This map consists only of noise without any faint Big Bang signals. The inconsistencies in the way the WMAP team works have also recently been pointed out by other scientists. Thus, two Chinese cosmologists note,
A remarkable inconsistency between the calibrated differential time-ordered data of the Wilkinson Microwave Anisotropy Probe mission, which is the input for map making, and the cosmic microwave background temperature maps published by the WMAP team is revealed, indicating that there must exist a serious problem in the map-making routine of the WMAP team. We find significant distortion from hot galactic sources. It will be very helpful if the WMAP team can thoroughly recheck their map-making process to find out where and how the error occurs, but until now they have insisted that their result has no problem, and prevented to discuss it with us.
The COBE and WMAP data show real observations regarding the monopole, the dipole, and the galactic component. The maps of anisotropies, on the other hand, are scientifically worthless. They show random noise and artifacts of data manipulation, nothing else. The WMAP team's claims that the small fluctuations are a reflection of the early universe suggest at best a far-reaching self-deception on the part of the scientists involved, and at worst a deliberate deception of the public in order to continue to collect huge sums of money for pointless research projects. This is the radiation of intergalactic plasma, which creates a fog in which we are moving, and through which we can see the faint glow of our galaxy. There is nothing more to see here.